Morphology. I'm Morphologist. I'm here on the Gallatin River to talk about three important things today, okay? The boundary shear stress, the critical shear stress, and the relationship between those two, as well as the Mannings equation, okay? So what is the boundary shear stress? That is the density of H2O times the force of gravity times the flow depth times the slope. So as the depth increases, so will our boundary shear stress, okay? The critical shear stress is our Shield's parameter times the difference between the density of the sediment times minus the density of water, right? Times the median grain size, okay? So as we have low flows like this, around 300 CFS, we're going to have a relatively low boundary shear stress. And let's say our critical shear stress is right here. As our flow increases, our depth increases, and our boundary shear stress increases as well, to a point where it becomes more than the critical shear stress. At this point, larger and larger particles will be mobilized and be able to tumble and go down the river through saltation or rolling. And this is how rivers erode. This is one of the processes. And the other thing we're going to talk about here is the Mannings equation. It's a measurement of velocity. That's velocity equal to hydraulic radius to the power of 2/3 times the slope to the power of 1/2 divided by the Mannings coefficient. What is the Mannings coefficient? That is an empirically derived number representing roughness. You can also calculate it if the depth, slope, and downstream velocity are known, but more typically people will just look at other known values of the Mannings coefficient and try to estimate what it might be for a system. So, yeah, looking at this system, I would say it's probably about 0.07 to 0.1. And let's say if we had a straight channel made out of concrete sides, that would probably have a Mannings coefficient of about 0.01. Okay, so as the the roughness increases, the velocity is going to decrease. All right. If you guys have any other questions, I will be with Dr. Doolittle.